Good morning, everyone. Welcome to the database tutorial number 3. I want to remind you what we have done in the previous two tutorials. We have seen the ERD, which is the entity relationship diagram, and then the extended form of it, which is the extended ERD. In both of them, the common things that were in both of them is the entities. The entities have their attributes and the relationships that connect them. The entities were like the abstract objects, the attributes were like the instance variables of any abstract object, and then the relationships that connect them that will give them a meaning. Now, all the relationships that we have seen so far always have connected two different entities with one another. So it's as if we are taking an instance from each and every entity together and we are linking them together as if they have a relationship with one another. Now, is it only possible to have a relationship between two entities? No, we can have a relationship between, which is called the ternary relationship. This is the notion of a ternary relationship. We can also have a relationship that connects more than that. However, the scope of this course will just be limited to ternary relationships. A ternary relationship in general is a relationship between three entities. So whenever I connect three entities, we are always talking about ternary relationship, a relationship that connects three entities. Sometimes it is possible to replace a ternary relationship with three binary relationships, whereas sometimes it is not. So it's not always the case that the ternary relationship is mandatory. We can replace it with three binary relations. So if I have, for example, in this example, project, product, and supplier, and these three entities are connected with a ternary relationship supplies, which connects them three together, we can split them into three binaries. I can connect the project with the product with the supplier, and the supplier with the product. And sometimes it is not. What we are going to discuss here is the problem that may occur if we replace it incorrectly. So if we do this replacement, which it was not required. Okay, the ternary relationship here in this example states the following, that a supplier, a specific supplier, supplies a specific product to a specific project. So it's as if I'm taking from each of the three entities one instance and I'm connecting them to one another. I'm just giving them a relationship with one another. Let's take a real life example. If I have the following, if I have that project 1 was supplied by supplier 1 with product 1, and project 1 was supplied by supplier 2 with product 2, and project 2 was supplied by supplier 1 with product 2, and project 2 was supplied by supplier 2 with product 1. Now we have two suppliers, two projects, and two products, and we have this scenario. These are some data that really happened. I'm taking an instance of every of the entities, of every one of the entities. Now, let's think of splitting this relationship into binary relations. So I have the project, I have the supplier, and I have the product. And I'm splitting this relationship into three. So what I'm going to do is the following. The project is having a relationship requires with product. So the project requires some products, and I have a relationship between supplier and product. A product is supplied by a specific supplier, and the project is assigned to a specific supplier. So it depends on every project, supplier, and product. So if we split or take this scenario into the binary example, what is going to happen is the following. I have project 1 was requiring product 1, and project 1 also required product 2. Project 2 required product 1, and project 2 also required product 2. Okay, type. I have that supplier 1 supplied product 1, and I have supplier 2 supplied product 2, and I have supplier 1 supplied product 2, and I have supplier 2 supplied product 1. And I also have that project 1 was assigned to supplier 1 for product 1, and project 1 was supplied to supplier 2 for product 2, and project 2 was supplied to supplier 1 for product 2, and project 2 was supplied for supplier 2 in order for it to give product 1. So we have the following data as split into 2 entities each. So if we want to return this piece of information, which I know is true because I have made this split or this instance as a consequence of the following data. So if I want to return this piece of information, I know, for example, that project 1 required product 1. I want to get to know this project 1 was given product by which supplier. I want to get to know the supplier. So I will need to go and search in the other tables or in the other information. So I will get to know which suppliers do supply product 1 in general. I have that supplier 1 supplies product 1 and supplier 2 also supplies product 1. So both suppliers do supply this product. So my only hope in order to get to know project 1 was supplied with product 1 from which supplier is to get to know project 1 was assigned to which supplier. So I will go and search. Project 1 was assigned to supplier 1 and was also assigned to supplier 2. So I will be confused. Project 1 got this product 1 from supplier 1 or supplier 2. I will be in confusion. Although I know for sure that project 1 was given product 1 by only supplier 1 from the ternary format or from the ternary example. So this split made me lose the piece of information of project 1 was given product 1 by which supplier. It is lost. Once an information is lost, then this transformation is an incorrect one. So this transformation is an incorrect one. It is not the same thing. It does not do the same job. So in this case, I'm sure that this transformation is wrong. Okay, one would ask me, when should I transform the ternary relationship into binary relationships and when should I not do that? The answer is the following. There is no rule. Unfortunately, there is no rule that I can tell you whenever you see it. For example, do the ternary relationship or do the binary relations. There is no standing rule that I can tell you. However, I will tell you the following. If you see that all the sides of the ternary relationship are many sides, then for sure this cannot be transformed into binary relations. This I can tell you for sure. I want to get back to you with how to do the cardinality and participation of ternary relationships in order for you to be able to do that in your project. If I want to get the cardinality and participation of this side, I will do the following. I will state if I have one project and one product, by how many suppliers at maximum can I get project 1 with product 1? By how many suppliers? If at maximum it's many suppliers, so for example supplier 1 and supplier 2 may give project 1 product 1, then it's many. So we will ask the same question but for the minimum value. If I have project 1 and product 1, by how many suppliers can project 1 be given this product? At minimum it's general 0. So and this is the cardinality and participation of this side. If we want to do it on the other side, if I have one supplier and one product, the supplier S1 for example and the product D1, to how many projects can it be given? At maximum many, because I can give it to project 1 and project 2. At minimum 0, I cannot give it to anyone. The other way around, if I have one project and one supplier, project 1 and supplier 1, how many products at maximum can be given by supplier 1 to product 1? At maximum many, and at minimum 0. So I will put the many sides and the 0 side. And hence, you can do the cardinality and participation of each side of those. Now, if all the sides are many, as you can see, then such a transformation is not possible. However, this is not a rule. I'm telling you that this is not a rule. So there can be other cases where we want to get to know some things about multiple inheritance. It's just a discussion on multiple inheritance. We will read these two statements and we will try to model them. Now, I have that every sponsor must either be a team, department, or club. No. Every sponsor must either be a team, department, or a club. Okay? And we have not every team, department, or club has to be a sponsor. Now, let us try to model this as a single inheritance, as having exactly one parent. Now, if we model it as a single inheritance, then we will have sponsor as a superclass, because every sponsor must either be a team, department, or a club. And we have team and department and club. And because these are the subclasses, I will just do the cup as opening upwards to the sponsor, because sponsor here is my superclass. Now, I want to ask myself two questions, as I told you. Now, are all the sponsors either teams, departments, or clubs? Yes, it's every sponsor. So I have a total participation. All the sponsors, everything in the sponsor belongs to one of those subclasses. Now, I must ask myself another question. Are they disjoint or overlapping? So can a team be a department, or a department be a team, or a department be a club, and so on? Or it's either or, because I have the word either, I'm sure that it's a disjoint relationship. Because not a team cannot be a department cannot be a team, and vice versa with the club. So this is for the single inheritance. Let's read the statement one more time and take a look at the given picture. Every sponsor, so all the sponsors, must either be, so I have the disjoint and I have the total participation, must either be a team, department, or a club. Okay, there is no problem. What about we do it the other way around? We can play. I will do it the other way around. If I put sponsor as the subclass, and I have team, department, and club as my superclasses. So I will put the cup upwards. So I have sponsor, team, and department, and club, and sponsor here is my subclass. Now, every sponsor must either be a team, department, or a club. Okay, so we will have here a union. Why is it a union? Because the sponsors are either one of its superclasses. So it's a union relationship. Now let's read the second statement. Not every team, department, or club has to be a sponsor. So not all the teams, departments, and clubs, say not everything in the superclass belongs to the subclass. So I will leave it as a partial participation. It will be only one line here. Okay, now let's read the two statements and take a look at this picture. Every sponsor must either be disjoint, and every sponsor must either be a team, department, or club. No problems up until now. So let's read the second statement. Not every team, department, or club has to be a sponsor. Yani the relationship between a team and sponsor does not always hold. What I have said previously is that the is a relationship must always be valid. So it must always be the case that an is a relationship holds between the subclasses and their superclasses. So it states that not every team, department, or club has to be a sponsor. So there can be teams that are not sponsors. Hence, this picture is wrong. because we cannot have a subclass of a superclass that is not necessarily a type of this superclass. If the SR relationship does not hold, then this picture is totally wrong. So this picture is wrong. We cannot describe this picture to model these two statements. Let's take a look at this picture and also read the two statements. What does it say? Every sponsor must either be, so I have the union, must either be a team, department, or a club. And not every team, department, or club has to be a sponsor. So I have the partial relationship because not everything from the superclass belongs to this subclass. Now, the two statements are correct. So I don't have any problem with this picture because I have the disjoint, the union as disjointing the subclass to one of the superclasses, and I have the partial relationship of the superclasses to the subclasses. So not everything from the superclass must belong to this subclass. So I don't have any problem with this statement, okay? But take care that in this case that we have only a partial part. Now we have two other statements stating the following. Every concert and fair must be a campus event. And we have also that every campus must either be a concert or a fair. Again, every concert and fair must be a campus event, and every campus event must either be a concert or a fair. Let's start drawing it. We have every concert and fair must be a campus event. We can draw the campus event as the superclass. And we have concert and fair as the subclasses. And we will draw the union cup looking upwards to the campus event because this is my superclass. Now, I will ask myself the very same two questions. Is it the case that all the campus events are either concerts or fair? Now, we will need to read the second statement. Every campus must be either a concert or a fair. So all the campus events are one of those. So I have a total participation because every campus event, everything from the superclass belongs to these two subclasses. طيب, is it a disjoint or an overlapping relationship? يعني ينفع يكون في concert and fair together overlapping? ينفع يكون concert that is a fair or a fair that is a concert? No, I have the word either. So I know for sure that this is a disjoint relationship. So okay, نقراها تاني. Every concert and fair must be a campus event. So the is a relationship holds. I have no problem. And every campus must either be, every campus, so I have the total participation, must either, so I have the disjointness, be a concert or a fair. So I don't have any problem with this picture along with the two statements. طيب, let's do it the other way around. If I have the campus event as the subclass, and I have the two superclasses, concert and fair. I will draw the cup as looking upwards to the concert and fair because I consider them to be my superclass. Right. Let's think of it again. Is it the case that all the concerts and fairs, يعني كل حاجة في superclasses belong to the subclass? نقرأ. Every concert and fair must be a campus event. Hence, كل حاجة في superclasses belong to this subclass. So I have a total participation. Okay? So I have a total participation. All the concert and fairs are campus events. طيب. هل the campus event is either a concert or a fair or can it be both؟ يعني نسيبها فاضية ولا نحط اليونيون؟ نقرأ. Every campus must be either a concert or a fair. So I have a union symbol to put here because it's either or. It cannot inherit from both at the same time. طيب. Let us read both statements and take a look again at the pictures. Now, let us consider firstly this picture. طيب. Every concert and fair must be a campus event. يعني كل حاجة في super class belongs to the subclass. تمام، عندي total participation مفيش مشكلة. طب every campus must be either a constant or a fair. يعني عندي union بيقول لي ان هو either يا اما constant يا اما fair، يعني هيدفرنشيت ما بينهم. اوكي، فانا عندي اليونيون تمام، مفيش اي مشكله. طيب let's read the two statements again and take a look at this picture. يعني انا هنا this picture is okay. طيب هل every constant and fair must be a campus event? Yes, every subclass is a type of its superclass. طب every campus event, then I have the total participation, must be either I have the disjointness, a constant or a fair. تمام، ما عنديش اي مشكله. طب what is the main difference between this example and the previous example? The main difference is in the participation, in the completeness of the multiple inheritance part. In the previous example, we had إن إحنا عندنا the subclass which inherited from more than one superclass had a single completeness أو uncompleteness. يعني كان عنده a single line، كان عنده partial participation. إنما هنا إحنا عندنا total، يعني عندنا إيه؟ إن كل حاجة is complete. In the case that it's complete, then both example cannot be reduced to the other one. Okay, this is a general rule. بس كده, and this is it for the inheritance. We will go on with the next thing we have to do, which is the relational model. We have the relational model, which is a transformation or a mapping from the ERD. Now, firstly, I want to introduce first some terminology that we are going to use further in the course, so you need to be familiar with it, and you need to know them by heart, because from now onwards, I will only use this terminology. Now, a relation, the word relation, is a two-dimensional table with columns and rows. Always when I state a relation, I'm talking about a table with some rows and columns. It's called always a relation. Now, my columns, these columns, are called attributes or fields. So any column is called an attribute or a field. Okay? If I want to count the number of columns, so I have here 1, 2, 3, 4 columns or 4 attributes, then this is called the arity or the degree of the relation. If I'm asking you about the arity or the degree of a relation, you will need to count the number of columns that you have. The next one, the rows are called tuples. If I'm talking about the rows of the relation, then I will call it tuple of the relation. A row is a tuple of the relation. And the cardinality is the count of the number of rows. Now, for the mapping, you have seen in the lecture that what we are going to do is the following. We want at the end of the day to map the ERD or the EERD, whatever, into its equivalent relational schema. Now the mapping is done as follows. We are gonna map each entity into a new relation. So we are always gonna have a new relation for each entity. So if I have an entity, for example, X, and it has, for example, 1, 2, 3 as its attributes. So I'm going to do the following. Each entity is mapped to a new relation, and each attribute is mapped to a new column. How are we going to map that? I'm going to write X, and then between brackets, the number of attributes that I'm going to have, which are 1, 2, 3. These are all my attributes. So this states the following. I have a relation named X with the following 3 attributes. If 1 is my primary key, I will underline it also here. I will have a line underlined over the primary key. Now, if I have multi-valued attribute, how am I going to map it into a relational schema? I'm going to have a new relation with the primary key of the entity and the multi-valued attribute. So let's say, for example, that 3 is a multi-valued attribute. I will not put it here. I will just have 1 and 2. And I will do, for example, a new relation named X1. هيبقى جواها ايه؟ The primary key of the entity which is 1 and 3. And both together they will form the primary key of this relation, of this new relation. Its primary key is gonna be the multi-valued attribute plus the original primary key. Now, if we have a weak entity, how are we going to model it? A weak entity is always also a new relation with all its attributes and the primary key of the identifying entity as part of its key. What does this mean? If I have, for example, here y as a weak entity, and it has, for example, m as part of the primary key, and the identifying relationship is with x. Okay? What am I going to do is the following. In the mapping, I will write y, and then between brackets, I will do the following. I will write m, and I will also write 1. Plus, if there are other attributes in the y entity. And the primary key of this entity is going to be m and 1. Together, they are going to form the primary key of this relation. Next one are the relationships. Now, if I have a one-to-one relationship, what does it mean one-to-one? If I have two entities and a relationship between them, if the maximum case in both of them, which is the cardinality, is 1, so I have here 1 and 1. This is I'm talking about the cardinality. I'm not considered here with the participation. If I have here 1 and I have here 1, what I'm going to do is the following. I will include the primary key of one entity as a foreign key in the other. What is a foreign key? The foreign key is using the primary key of one entity into another entity. So I will use the primary key. I will just map the primary key into the new relation. If I have, for example, here x and y, I will have two relations, x and y, with all its attributes. For example, let's say x1 is this attribute and its primary key, and here is y1, and this is the primary key. So I have here x1, which is underlined, y1, which is underlined. I will make my choice. Either I will take y1 here as a foreign key, or I will take x1 here as a foreign key. I will make one choice only. I will only map one primary key as a foreign key in the other. This is in case one-to-one relationships. But if I have one-to-many relationships, يعني I have at one side 1 and at the other side many, I will put the primary key of the one-sided entity as a foreign key in the many-sided entity. So if I have here many sides and here is one-sided, I will take the primary key of the one-sided and put it as a foreign key in the many-sided. There is no choice here. I am obligated to take the primary key of the one-sided and put it as a foreign key in the many-sided. In the case of the many-to-many relationship, I will create a new relation. It's always the case that I will need a new relation with both primary keys of the two entities together as forming the new primary key. So what if I had here many and here many? What I'm going to do is the following. I'm going to create a new relation with both primary keys, x1 and y1. Extra, as an extra relation other than the x and y entities. And here the primary key is gonna be both of them. Okay? Now, for the ternary relationships, in case the ternary relationships, we are gonna have also a new relation with the primary key of the three entities. So it's similar as of the many-to-many relationship, or a relationship between the entities. Also in the ternary relationship, we will consider the primary key of the three entities in a new relation. Now we are done with all the possible combinations. We will now try to solve an exercise in order to see how the mapping works. This is the first slide that you are going to see in the practice assignment, which is just agreeing upon the formatting guidelines that we are going to follow in order to map the ERD into a relational schema. A relation in the schema should be in this format. As I told you, we will have the name of the relation along with all the attributes in parentheses, where a relation's primary key should be underlined, so every primary key must be underlined. A foreign key should be underlined using a dashed line, so I will need to have a dashed line in order to underline the foreign key, and I will need also to have, for each foreign key, the attribute it references should be stated, should be clearly stated in an English statement. I will show you how. And any additional constraints on a relation should be stated. So if we have anything that should be calculated or anything that should be stated, any constraint should be clearly stated. For example, we have the following example. A student has a student ID, S name, and birth date, and course has a CID and C name. And we have enrolled with CID and CID. SID for the student and CID for the course, who are both a primary key also as well as foreign keys because they reference the primary key of another relation. Also, we need to state, as I told you, enroll.sid references student.sid and enroll.cid references course.cid, because I need to state for every used foreign key which primary key it references from the other table. So this is a small example. Let's try to solve one together. Now we are given the following ERD, which is formed of the following entities. We have the entity employee, which has SSN salary and phone number as its attributes. We have the entity child with name and age as its attributes. We have the entity department with department number, budget, and name as its attributes. And we have project with project ID type, E-date, S-date, and duration. Now, there are also other relationships which link the different entities with one another. Let's start with the mapping of this ERD into the relational schema. Now, the first entity that we have is employee. So, because employee is a standalone entity, then it will be mapped into a relation on its own. So, we have the relation employee, which has the following attributes: SSN and salary and phone numbers. But phone numbers here is a multivalid attribute, and as I told you, in case that we have a multivalid attribute, then it will be mapped into another table, and the primary key of employee is SSN. Okay, but in the other table, in this phone table, what are the attributes that are going to be there? It's going to be the primary key of the original table, which is in this case the SSN of the employee, plus the multivalid attribute itself, which is the phone number. So I'm gonna have here these two attributes. And what is the primary key of this newly instantiated relation? It's both together. Both are gonna form the primary key of phone number. And because SSN is the primary key of the originally of the employee table, then here it is called the foreign key, and I will need to dash it. Also, I will need to do the reference. So I will need to state that phone.ssn references employee, because this is not its attribute, but it is referencing it from another relation. Now, let us get to the next entity. We have the entity department. What attributes does a department have? It has department number, budget, and name. And the primary key in this case is the department number. And next, we will have the project entity, and its attributes are the project ID, type, E-date, S-date, and duration. The primary key in this case is PID. But duration here is not a normal attribute, it's a derived attribute, which means that it can be calculated or derived from other attributes. So we need to state all these constraints in an ERD, in the relational schema. So we will state where project dot duration, and I will need to get to know the formula with which the duration is calculated. I have the end date and the start date, so it's probably the end date minus the start date. With this difference, I will get the duration of the project. Now I'm done with all the strong entities. I still have the child as the remaining weak entity. So I will have child as an entity. What attributes does the weak entity have? It has its own attributes, which is name and age. And it will also have the primary key of the identifying relationship that it inherits from the primary key in order for it to be uniquely identified. So how will I get to know this entity? I will get to know it from the double rampus. I will need to search for the double rampus in order to get to know what is the entity from which it inherits or it borrows the primary key for it to be uniquely identified. In this case, it's the employee. So I will need to add the SSN of the employee as part of the attributes of the child entity. In this case, what are the primary key of the child entity? It's going to be name, which is the part of the primary key in the child entity, and the SSN together. They will form together the primary key, or what is going to define the child uniquely. Okay? But since SSN is not the original attribute of child, it is borrowing it from employee, then it is also a foreign key. And I will need to state that child.ssn references employee in order to state exactly what the foreign key here is referencing. Now we are done with all the entities, and now we will get to the relationships. Now we will start, for example, with the manager's relationship. This relationship links the employee with the department. It tells us which employee manages each department. Now we will need to get to see what is the cardinality on both hand sides in order to decide what is the step to do. So I will go and take a look at the cardinality here, which is the maximum case, which is 1. And I will go in the other hand side and I will take a look. This should be the other way around. It's 1 or 0 because 0 is only in the participation. But I'm here only interested in the cardinality, اللي هي ايه? The maximum case, which is 1. طب if it is a one-to-one relationship, what did I say? If it's a one-to-one relationship, then I can get to decide. I can either put the SSN of the employee in the department relation, or I can put the department number, primary key of the department, in the employee relation. طب what is better in this case? يعني, is it better to put in the relation of employee, in the table of the employee, the department number? يعني هل ده معناه عند كل employee I have a department number that they manage? I don't think so, because there are so many employees that are not managers. فعندهم الvalue دي هتبقى ايه؟ هتبقى null علشان هما they are not managing any kind of departments. طب what if we do it the other way around? لو انا رحت عند department و I added the manager SSN, the SSN of the manager that is managing this department, هل هيبقى عندي اي nulls؟ انا هيبقى عندي relation table كده جواها some rows, and in each row there is a specific department, and I will have and in one of its the columns the manager SSN. طب ما اكيد عند كل department لازم يبقى فيه SSN because every department has a manager. So it is the case indeed better to put the SSN of the employee as an attribute هنا. I can name it anything, so I will name it here as a manager. The naming is my option, so you can name it the way you want. And I will name it manager for it to be more readable. فأنا هخليها دي foreign key. هو اسمه manager, however, what is it actually? It is the SSN of the employee. So I will need to do it as a foreign key. I will need to dash it, and I will need to do the reference. I will need to state that department dot manager references employee. Hence, I'm done with this relationship. أنا كده عندي managers اللي relate an employee with the department. And we have seen that it's better in this case to put the SSN of the employee as a foreign key in the department. Let's take the next relationship, works in. Works in is of what type of relationships? We need to look at the cardinality in both hand sides. طيب, the cardinality هنا is what? Is many. طب والcardinality هنا is what? is 1. يعني أنا عندي هنا a relationship of type 1 to many. طب what do I do with the relationships that are of type 1 to many? I will take the primary key of the one-sided entity and put it as a foreign key in the many-sided entity. So I will take the department number and put it as a foreign key in the employee. So I will need to add في employee هنا department. Department D is a reference to the department number that I want. طب department دي عبارة عن إيه؟ It's a foreign key. So I have only cleared the page in order for us to be able to see better. What is left is to do the reference. So we need to add employee dot department references department and then we are done with this relationship. And we are also done with this relationship. Let's take a look at this relationship. What type is this relationship? It's of type many to one. It's here many sides and one-sided. What do we always do in the many to one-sided? We will take the primary key of the one-sided and put it as a foreign key in the many-sided. If we take a look at the child relation, if you remember from the previous statements, in the child, because it's a weak entity, we have already put the primary key of the employee as a foreign key in the child. So we will not need to duplicate it. It's already there. So this relationship is handled by default. We don't need to do it. Now, the last relationship that is there, it's involved. What type of relationship is it? It's a many-to-many relationship. It has on both sides many. And what did I say about the many-to-many relationships? We always do a new relation. So it's relation, it's involve. And what attributes will it have? It will have the SSN, the primary key of the one entity, and also the primary key of the other entity. And in this case, we have an attribute on the relation. It's like the accept attribute that we have seen previously. So all the attributes that are on the relation are going to be put with the same relation. So I'm going to put task here as an attribute in this relation. And what are the primary keys in the involved relationship? It's going to be both together, the SSN and the PID. We are not going to put the task as part of the primary key. And they are also foreign keys because we are actually using the primary keys of other entities. So we also need to do the reference. So we have involve dot SSN references employee, and we also have involve dot PID references project. And now we have the many-to-many relationship with the attribute of it, and we have the references. Hence, this relationship is mapped correctly. So we have all the mappings. We have the employee, we have the child, we have this relationship, we have the department, and we have the project, and we have here this together with what we have seen before I do the erasing of the previously done entities. All of this together form the relational schema of this ERD. This is the mapping of the ERD. The advantage of this mapping is that you see something similar to the relational database, something similar to what you are going to really store. So I can see that this is a table with the following columns, and I can see that these are foreign keys that reference other tables, and so on. So this is easier to see and easier to work with further whenever we get to the querying stage. So this exercise is done, and we are going to the next exercise. We are given the following ERD, and when we want to determine the problems of the following mapping. So we are given here some mappings, and we want to get to know their problems. Okay? Now, the first mapping is as follows. We have the A as the entity, so it's mapped as a standalone entity, which is correct, and we have A1 and A2, okay, and they have B1 as a foreign key. Okay, And we have the B entity, which is also mapped into a standalone relation with B1 as the primary key, B2 and A1 as a foreign key. Okay. And C is having C1 and C2, and C1 is the primary key. And they mapped R2 relation into a standalone relation, into a relation on its own, with B1 and C1 is the primary key in this case. Okay, let's see the problems of this mapping. First of all, for the relations, each and every entity is mapped into one relation with its attributes. But in the first case, in the first R1 relation, it was mapped twice. It was mapped as putting the A1 as a foreign key in B and putting B1 as a foreign key in A. Firstly, this is redundant because we only need one reference. We should not have both. One of them was enough. So if we neglect A1 or neglect B1, one of them was enough. So we don't need to do both. So first of all, this is redundant. We don't need to do that. Second of all, doing this, requiring this, may cause some redundancies and inconsistencies. For example, if we have in this relation the value 1 and the value A for B1. So this is the value of A1 and this is the value of B1. And we have here in this table for the value B1 A and for the value of A1 2. What will this do? Here, this is a primary key, so 1 is not going to be repeated anywhere else in this table. So it says here that the value 1 in A1 is related with the value A of B1. And it says from the other relation that the value of A in B1 is related with the value of 2 of A. Do these two state the same thing? No, they do not state the same thing. Although they should be consistent, because this is at the end of the day a foreign key to this table, and this is at the end of the day a foreign key to this table. So this should not be allowed. This is called inconsistent because this is not giving me a consistent information. It's telling me that 1 is related with A, and from the other table it's telling me that A is related with 2. So A is related with which one? Is it related with 1 or 2? I'm gonna be confused. So this confusion is causing the inconsistency because you are confused, hence you have an inconsistency in your relation. Also, it does not enforce what we call the one-to-one constraint. Why is it the case? Because if we consider the following, if we have the following that, for example, in this case, we have the value 1 for A1 and for the value B1, the value A, and we have for the value 2 also A. What does this do? It will tell us that the value 1 of A1 is related with the value A of B1, and the value of 2 for A1 is related also with the value of A from B1. So I have two different values for A1 which are related with the very same value of B1. Which is not what is said in the ERD. It is said that these are always related with exactly one interaction between both. So A1 is related with exactly one of the B1, and B1 is related with exactly one instance of the A1. So we cannot have such a thing. This is called the one-to-one constraint is not maintained. This is violating the one-to-one constraint. This is not maintaining the constraint that every and each one of these two entities are related with exactly one of the other entity. So these are mainly the problems of this mapping. Let's take a look at the next mapping. Here we have A having A1 and A2, B having B1 and B2, and C, here we have A1 and A2, here we have B1 and B2, and here we have C1 and C2, and R1 is mapped as follows. We have that A1 and B1 is mapped in a new relation where A1 is the primary key. It is equivalent as putting B1 as a foreign key in the A relation. It's equivalent to it. And we have B1 with C1 in a new relation. Okay. Now, let's take a look at this relation. The problem with this relation is mainly here. with also the one-to-one constraint. Here is also the one-to-one constraint not maintained, because I can have a value 1 for A1 related with the value A of B1, and also the value 2 of A1 related with A. This kind of relation does not constrain me or does not force me to follow the one-to-one constraint. It will not force me. So I can have two different instances of A related with exactly the same instance of B. So this will cause me a problem. Let's take a look at the third instance. We have here A1, A2, and B1, which is the foreign key of B1. Here we have B1 and B2, and they have the foreign key of C put in B, and we have C1 and C2, which will also do the mapping of C into a new relation with two different attributes. Okay, the problem, as always, it is here in the one-to-one mapping, because the one-to-one mapping is not maintained. It is correct, it is a correct translation. However, the one-to-one mapping is not maintained. We can also have two different values of A related with exactly the same value of B. So this will cause us a problem. In the next relation, we have, for the R2 relation to be mapped, they have put the C1 as a foreign key in B1, which is a correct transformation. So in this example, only the one-to-one mapping is not maintained. The last option, we have A1, A2, B1, B2, and A1 as the foreign key. So they put the foreign key of A1 here. And we have the table, the relation C with C1 as the primary key, C2 and B1 as also part of the primary key. Now, as always, the one-to-one mapping is not maintained. Is violated here, because also we can have two different values of B related with exactly the same value of A. So the one-to-one mapping is violated. And we can also have a problem with the mapping of R2, because what they have done is the following. They have put the many-sided attribute as a primary key in the one-sided entity, which means that we can have a record of C can be related to more than one element of B. So we can have, for example, 1 with A and 1 with B. Although it has said that the one value, and we can have also, for example, A mapped with 2. Although it has said in the ERD that the one value of C is related with several values of B. However, the one value of B is related with exactly one value of C. So if I have A as a value of B1, I have A as an instance of B1, then I should always have exactly one value. I cannot have two different values for the very same instance of B, because it has said in the ERD that the one instance of B is related with exactly one instance of C. So this will cause inconsistencies. This is treating it as if it's a many-to-many relationship. We can have different values of C related with different values of B, and different values of B related with different values of C. So this is not maintaining the one-to-many constraint. The one-to-many constraint is here violated. Too-many constraint is violated. These are mainly the problems. You can see other problems. Just think of the other alternatives and why are we doing this. However, there is a very important point that you should have noticed. In all of the possible scenarios, even in the ones that we accept and that we follow, the one-to-one mapping is not maintained. The one-to-one mapping in the relation schema cannot be maintained. We cannot enforce that the value of the foreign key be unique. We cannot enforce it in the relational schema. However, in SQL, in the real SQL, you can enforce that. You can state that this, for example, this column is a unique column. You can state that. Hence, you will not be able to repeat any A. You repeat the B with different A's. So you can maintain this constraint in the real database. However, here in the relation schema, we don't have access to do that. Now, we are going to go to the next exercise. We have a ternary relationship, supervise. that links a student with a professor and a seminar. And let's just try to read it. We have that the professor and the student are just being supervised under one seminar. And if you have one professor and one seminar, it's given out to several students. And if we have one student and one seminar, then it's given by exactly one professor. And there is a grade that depends on this relationship. Okay? So let's decide whether the following combinations can be taken as a candidate key satisfying all constraints in the ERD, yes or no. So the first proposal is to put the professor ID, student ID, title, and grade as together in a relation, and decide for the professor ID and student ID together to form the primary key of this ternary relationship. Let's see if this can happen, yes or no. Now, what is actually the primary key of this ternary relationship? Is it the student ID and professor ID together? No, it is not the case, because if we have exactly one student, then they will have exactly one professor and one seminar. What does this mean? That the student will always be repeated once, because I will only have to keep track of them once, because if I have a student, then they are rated with exactly one professor and one seminar, and they will have exactly one grade. So the student on its own is a super key, because this should not be repeated, because I only have one student who is related with one professor and one seminar. So the student ID on its own is a super key. Hence, professor ID and student ID together are not a candidate key. So this is not a candidate key on the first place. Not a candidate key. So, does it refrain any constraint? Let's see. If I have professor ID 1 and student ID 1, I can repeat the professor ID. If I state that this is my professor ID and this is my student ID, I can repeat the professor ID with different students, and I can repeat the student with different professors, because both together form the primary key, so both together cannot be repeated. However, everyone on its own can be repeated. So does this apply the constraints mapped in the ERD? No, it does not, because here a student should only have one professor teaching them, or you should have only one professor supervising them. This says that we have two students with two different professors. So this does not maintain the constraint of having a student being taught by exactly one professor. Let's see the next proposal. They propose here to have the student ID and title together to form the primary key of this relation. Now, can we state that student ID and title together form the primary key of this relation? No, because it's also not a candidate key. Because student ID on its own is a super key, so we don't need title with it in order for it to be a primary key of this relation. Okay, let's see what constraints does it violate. If I have student ID and I have title, this means that student 1 can have title X and student 1 can have title Y, which means that the very same student can have two different seminars, can have two different titles for their seminar, which is not stated in the ERD. In the ERD, it is stated that the one student has exactly one seminar and one professor. So we need to enforce that the student should not be repeated with different seminars. So this violates the constraint that a student has exactly one seminar assigned to them. Let's see the last proposal of having the three together as the primary key of the relation. The professor ID, student ID, and title together. Also, like the previous two cases, it's not a candidate key, so it cannot be a primary key of the table. What constraints does this violate? It actually violates all constraints, because a student in this case, the one student, can have different titles and different professors. And the one title can be taught by different professors for different students, which is not stated here. The one seminar should be taught by exactly one professor to many students. However, the one seminar, if I have one title, then it should be taught by exactly one professor. And this is not maintained if I have all of them 3 as the primary key, because I can have all possible combinations of the title, student ID, and professor ID in my table without having any problem. So it will violate this condition. Hence, all the 3 possibilities are wrong. Now, I want to present some terminology, some other new terminology. We have the integrity constraint. Integrity constraint is what is a condition that must be true for any instance of the database. What does this mean? That if I take any tuple at any time, any tuple, any value of the database at any time, all the integrity constraints must be satisfied. The most famous integrity constraints is the primary key, for example, cannot have a null value because it must be unique. So a null value is not a unique value. So one of the integrity constraints that whenever you take any tuple at any time from the database, you will always have a value for the primary key. There are other integrity constraints that you will get to know about. However, you need to know this terminology, that integrity constraints means that these are the conditions that should always hold for any row of the table. And then we will have the entity integrity, which means that in a relation, no attribute of a primary key can have a null value, which is exactly the example that I have used to explain the integrity constraint. Entity integrity is one example of the integrity constraint. It is an example of it, that the primary key can never have a null value. Okay. The foreign key, which I already described previously while discussing the mapping of the relational schema, is a set of fields in one relation that is used to refer to a tuple in another relation. It's as if I'm pointing to a row in another relation. The primary key is the one allowed to be used as a foreign key in another relation. So we are always using the primary key of one relation as a foreign key in another relation. We cannot use any other attribute. And we have what we call the referential integrity. What is the referential integrity? Is that the database does not include any invalid foreign keys. That means if I have a foreign key that is referencing a primary key of another table, I cannot reference something that is not there. I should always be able to reference something that I can access. I cannot reference something that is not there. Okay? So if I delete something, then everything that it references should also be deleted. I should handle that. Okay, let's just here choose one of the possibilities to be the correct answer. What is the referential integrity that I have just explained? Makes it possible for an attribute to have a corresponding value, or requires that every null foreign key value must reference an existing primary key value, or requires that every non-null foreign key value must reference an existing primary key value, or makes it possible to delete a row in one table whose primary key does not have a matching foreign key value in another table. Clearly, it is this option, which requires that every non-null foreign key value, so whenever I have a foreign key value, I must reference an existing primary key value. I cannot reference something that is not there. So this is the correct answer. The next one, consider the foreign key CNO in the payments relation. This one. Let's just understand the schema that is given. We have building number, it's the primary key of the table, area, zip code, and build. And we have the table contract, which has the contract number as the primary key and several other attributes. And we have the apartment as the next relation with the building number and the apartment number together forming the primary key. And we have the payments, which has the foreign key of the contract number and the date that together form the primary key and the amount. Now, in the first question, we want to consider the CNO of the relation payments, which references contract. So we have CNO, which references contract. Which of the following operations can never violate the foreign key? Insertions into payments. Okay, let's think of the first example. Can I insert something into payments and as a consequence of it, I will violate the referential integrity, the foreign key? Yes, because I can, for example, add something like 1005 and some date and some amount. Is the 1005 referencing something that is there? No, so it may violate the foreign key constraint. So this is not the correct option. Now, deleting from payments. if I delete from payments, if I ever delete something from payments, am I going to do any harm to the primary keys of the contracts? No, if all of them are already satisfying the constraint, so deleting any row from the payments will not cause anything regarding the referential integrity. So deletion from payment is the correct answer. Let's take a look at the other one. Deletion from contract. If I delete from contract, can I violate the foreign key? Yes, because if I have these examples and I, for example, come to delete this very last statement, this 1003 is gonna reference something that is not there. So it's gonna violate the foreign key constraint. Hence, this is only the correct answer, which is deletion from payments that will not violate any foreign key constraint. The next exercise, consider the same schema. Which of the following statements is correct? Consider only the stated records belong to building relations. So we will consider as if only those two tuples are the ones, tuples or records. Records is another word for tuples. These are the only two records of this table. Consider only these statements. We want to see if the cardinality and the arity of the relation of building are equal, if the cardinality is equal to 2 and the arity is equal to 4, or if the cardinality is equal to 4 and the arity is equal to 2. What is the cardinality? I have stated them in the beginning of this tutorial. The cardinality is the number of rows. What is the cardinality in this case? It's 2. Now, what is the arity? It's the number of columns, the number of attributes. I have here an arity of 4. So I have an arity of 4 and a cardinality of 2. So it's the second option. The cardinality is equal to 2 and the arity is equal to 4 in this case. Now, the next exercise, if the primary key of the relation may contain a null value as a value of their components, as an answer, it is false. A primary key can never have a null value as a value of its components. It's always a rule. It will, if it does that, it will refrain the entity integrity. And entity integrity is a specified rule of every database that exists. The next exercise, a relation schema can have multiple, more than one candidate keys, multiple, more than one primary key, no key, or none of the above. It may have actually multiple primary candidate keys. It cannot have multiple primary keys. Primary key is exactly one chosen. It's exactly one chosen candidate key. So I have only one primary key always. I cannot have no key. Every relation in the database has at least one key, and truly we have one correct answer, which is that we can have more than one candidate key in this case. And hence we are done with the third tutorial of the course. Thank you so much for listening, and I hope that this was clear enough, and I hope that the concepts have been grasped smoothly. Please do not hesitate to contact me if you have any further questions, so that you are not lost anywhere in this course. Thank you so much again, and I wish you the best of luck.